Okay, let's do a bunch of examples of finding the derivative at a particular number. Okay, so here we're given a function. I want to find the derivative. That's what that little prime means. The derivative of f at x equals 2. So using this version of the definition, this is what a proper write-up would look like. F of 2 is the limit as x approaches 2, that's the guy I care about, of, and I'll write this out formally here. So all I've done is replace all the a's with the 2. And that will equal the limit as x approaches 2. Well, what is f of x? That's 3x squared minus 4x plus 1. That's f of x minus f of 2. Now I'm going to be subtracting a bunch of stuff here, so I need to put a bracket here. That's going to be 3 times 2 squared minus 4 times 2 plus 1, and that's all over x minus 2. So this right here was f of x minus, here's f of 2. Make all that a little smaller so I have space. Okay, let's clean up a little bit. Okay, so what do we get here? This is just going to be a number. So that'll be what, 12? I'm going to put it over here on the side. So that's 4 times 3, that's 12 minus 8 plus 1. So that would be, I think we get 5. So this would be 3x squared minus 4x plus 1 minus 5. All over x minus 2. Okay, now we can combine some like terms there. Limit as x approaches, let me write that prettier, 2 of 3x squared minus 4x minus 4, all over x minus 2. Now, what you would like to try is just plugging in 2. Anytime you're asked to find a limit, first thing you want to try is just plug it in. But you can check this on your own. If you do, you're going to get 12 minus 8 minus 4. You get 0 over 0. That means something's going to cancel. And in fact, you know what's going to cancel. It's going to be an x minus 2. So that means I know I can factor. You got to be an expert at factoring in this class. I know one of the factors has got to be x minus 2 because that's what's going to cancel out. So now we can just kind of work backwards and figure out what the other one needs to be. I know I have to have a 3x here so that I get 3x squared. And in order for this to be minus 4, I think this has to be plus 2. Now we could FOIL and check and see if that's right. So we would get 3x squared minus 6x plus 2x, that's minus 4x minus 4. Hey, look, the x minus 2 cancels. And I get limit as x approaches 2 of 3x plus 2. Now I don't have to worry about 0 over 0. Now I can just plug in my x equals 2. Just keep making that uglier. So now we just plug in 2 and we get 3 times 2 plus 2. What is that? 6 plus 2, we get 8. So the slope of the tangent line to this graph when x equals 2 is 8. Okay, that's using that definition. Again, this is not my favorite. I like this definition better. So let's do it using this definition. This is the one I'm going to have you do on the test. So f prime at 2 is supposed to be the limit as h approaches 0 of f of 2 plus h minus f of 2 all over h. Just for simplicity, I'm going to rewrite what our function is over here. It was 3x squared. I don't remember. That's why I'm writing it down. Minus 4x plus 1. Yeah. Okay. F of 2 plus h. That means rewrite the entire function. But now, instead of writing x's, every place I see an x, I'm going to write 2 plus h in parentheses. So this will be 3 times 2 plus h squared minus 4 times 2 plus h plus 1. That right there, what I've just written, that's just f of 2 plus h. What am I supposed to subtract from that? F of 2. And I'm going to need a bracket here because I have to subtract the whole thing. So now, just this piece, replace all the x's with a 2 in parentheses. So I'm just pausing, give everybody a chance to look at that. This is f of 2 plus h. All of this chunk here was that other part, f of 2. And then don't forget, a lot of mistakes happen here. Look at that guy. That's a fraction. That's over h. This also needs to be over h. Okay, now we just clean it up. It's just algebra from here. So this will equal the limit as h approaches 0. I have to write that at every step. All right, we're going to be squaring a lot of binomials. In fact, it's probably a good idea just to remember that a plus b squared is always going to be a squared plus 2ab plus b squared. Anytime you're squaring a binomial, you're going to get something that follows this pattern. And you're going to be doing that a lot. So it's good just to memorize that. So PEMDAS, I have to follow order of operations. That 3's got to hang out for a minute. And I have to square this guy. So that's going to be the first one squared, 4. Then multiply them together and double it. So 2 times h times 2. So 4h. And then square the second one. If that had been a minus there, we would have a minus here, but it's not. Okay, let's distribute everything else. So minus 8 minus 4h plus 1. And then let's clean all this up. I think we actually, didn't we find that number a minute ago? It was just 5. So all of that just turned out to be 5. All over h. Okay, let's distribute. So limit as h approaches 0, what do we get? We get 12 plus 12h plus 3h squared. Let's see, we got minus 8, minus 13 plus 1, minus 12. And then there's that minus 4h. And that's all over h. I think I got everybody. Oh, look, the 12s cancel out. And everybody that's left has an h. In fact, I could combine these together. I would like to keep this going. It looks better if all your limits are lined up, but yeah, maybe I can squish it in here. Limit as h approaches 0. we've got 3h squared plus 8h over h. Let me pause a second. Okay, here, everybody has an h on top. If somebody on top doesn't have an h, you've done goofed. And yeah, I'm going to squish it in here. Equals limit as h approaches 0, factor an h out on top. I get 3h plus 8 over h. The h's cancel. Then I can plug in h equals 0. I couldn't up here, but now I can. And I'm going to get 3 times 0 plus 8. I get 8. And that is the derivative of our function at x equals 2. And look at my nice chain of equal signs here. So I've started with f prime at 2 equals, writing limit all the way down until I actually take the limit. Okay, let's do another example. This one's actually easier, but people have a little more trouble with it. So f prime at -1 should be, and you need to memorize this, limit as h approaches 0, f of -1 plus h minus f of -1 all over h. Okay, f of -1 plus h means rewrite the function, but now instead of writing x, all of this is going to go right there in that x. 5 -1 plus h plus 4. Don't forget that. So that right there is this. Minus, and then I'm going to need parentheses here. A lot of mistakes happen here too. F of -1 would be 5 times -1 plus 4. And then all over h. Don't forget the over h. And now we just clean up. So nothing's squared here. I don't have to worry about any of that stuff. This is just all linear. Just clean it up. Limit as h approaches 0. What do we get? -5 plus 5h plus 4 plus 5 minus 4 all over h. And all these numbers cancel out. I get 5h over h. So I get limit as h approaches 0 of 5h over h. H cancels. I just get 5. I just get a number. I don't even have to plug anything in. This is a line. His y-intercept is 0, 4. And his slope is 5. So if I go over 1, 2, 3, 4, 5, over 1, up 5, there's another point. So lines tangent to this graph are the graph itself. Linear functions are their own tangent lines. The derivative of a linear function is just the slope of the line. So look, that's what I ended up getting. I just got the slope of that line. That's going to happen every time. If your function is just a line, then the derivative at any value is just the slope of that line. So derivatives spit out slopes of tangent lines. So we could do this graphically. F prime at 1. So I'm talking right here. What is the slope of this line itself? This line is tangent to itself. So I would want the slope right there. F prime at 1 is that slope. So that looks like that goes from the point 0, 1 to the 0.46. So that's 2 points on the line, 0, 1, and 4, 6. So f prime at 1 would just be changing y over changing x. 6 minus 1 over 4 minus 0. I think that's 5/4. F prime at 6 is saying, okay, what's the slope here? Is this slope. We could just look at it there and get that. I'm going over 2, up 1. That's a slope of 1/2. Up 1 over 2. The derivative is the slope of a tangent line at a particular point. All right, that's a good place to stop for that video.